Good morning, everyone. My name is Victor Hugo Guerrero, and today I'm going to share with you some of the results that we have obtained in a study regarding methomyl removal from synthetic water using natural and modified bentonite clays. I will give you first some ideas about the pollution by pesticides and some of the options that we have for removing this type of contaminants, particularly using adsorption. Then I will define the objective that we established for our work as well as the methodology that we used. And I will present some of the main results that we have obtained and the conclusions we derived from our work. Agriculture is the activity that uses the most pesticides, whose main purpose is the management of pests and diseases that could reduce crop yields. However, only a small portion of the pesticides applied affect the organisms that were intended to be eliminated. Actually, a larger portion could go to the environment and can contaminate the environment. Particularly, methomyl is an insecticide which is part of the carbamates. This insecticide is used around the world and has been classified by the World Health Organization as toxic and dangerous. Methomyl is highly soluble in water and has low absorption affinity to soils. Therefore, methomyl can easily cause groundwater contamination in agricultural areas, particularly. Because of the problems associated with methomyl in different ecosystems, there is a need to eliminate this contaminant and some other similar contaminants. However, the technologies that are available for removing this type of contaminants are not very efficient, and in many cases they are also very costly. So there is a need to find and to develop materials, procedures, technologies that can be used to remove methomyl and some other insecticides from the environment. In our case, we focused on absorption since absorption is highly efficient and offers many different possibilities. Particularly, we can use clay to absorb some contaminants because clay is one of the most economical materials that can be used for this purpose. And among the clays, bentonite is one of the most widely used adsorbents, and it is activated usually to improve its contaminant removal efficiency. So, having this in mind, we defined for this study as an objective to evaluate the removal of methomyl from synthetic aqueous solutions using natural and modified bentonite clay as an adsorbent. For that purpose, we obtained and we activated some clays, and we characterized these materials using infrared spectroscopy, X-ray diffraction, BET, and we performed some batch absorption tests for methomyl removal in our case. Well, the clays that we obtained were bentonites, and these clays were first conditioned by washing them, drying them, removing organic matter and carbonates, and these washed clays were called purified clays. We took these clays and we sieved these clays to obtain 3 different particle sizes that you can see here. And with these clays, we performed 3 different activation processes. We performed thermal activation by heating the clays at 200 degrees Celsius, an acid activation using sulfuric acid, 3 normal, and saline activation using hexadecyl 3-methylammonium bromide, a salt which was used in the activation process. With the clays that we obtained, the natural, the purified, and the activated clays, we performed some absorption tests in which we used clay doses of 10 grams per liter. We used a stirring rate at 120 RPMs and a contact time of 3 hours. We performed these studies at 3 different temperatures, 20, 30, and 40 degrees Celsius. So here are some of the results that we obtained. Here you have the X-ray diffraction pattern of the natural and modified clays. As you can see here, the natural clay has a peak corresponding to the 001 plane of the monorillonite. And this peak moved a little bit to the right. in the case of the activated clays using the thermal process and also in the case of the activation performed uh, using the saline, we have a movement of this peak, but in this case to the left. So it increased the interlayer spacing in these saline activated clays. Here you can observe the infrared spectra for the natural and the modified clays. As you can observe, there are some bands corresponding to the bond stretching of the hydroxyl groups. The absorbed water also is shown in some bands, and also there are some bands corresponding to the case of the silicon oxygen bonds, and also to the aluminum oxygen silicon that we have here in the materials that we were using. In the case of the saline activated clays, we observed some bands corresponding to the salt that we used for this purpose, which was hexadecyl trimethylammonium bromide, as I said before. In our case, we also performed some BET analysis to be able to determine the specific surface area of the clays that we used. Note that the natural clays had a relatively high specific surface area, but when we used the thermal activation process, we increased this specific surface area, and also the pore volume increased in this case for these materials. For the acid activated and for the salt activated clays, actually the surface area and the pore volume reduced. So from these results, we were able to see that these thermally activated clays will have a good performance during the absorption processes. So we performed the analysis, the batch tests, and we observed that when we were working at 20 degrees Celsius, basically the best clays that we observed were the ones that were purified. These purified clays have a removal efficiency around 50%, as you can observe here. When we were working at higher temperatures, the thermally activated clays had better performance, and also we improved the performance of the purified clays, as can be seen here in these two cases. When we were working at 40 degrees Celsius and with the larger particle sizes, we obtained a removal efficiency around 75% in our case, using the thermally activated clays, as I said. So these were some very nice results. So we took these results and we fit the results to the Langmuir and Freundlich models. Actually, our results fitted best the Langmuir isotherm model, and the statistical analysis that we performed showed that there was a significant effect for the interaction between the temperature that we used during our tests, the clay that we were using, and the particle size, the diameter of the clays that we were studying in our case. So with these results, we were able to derive some conclusions. First of all, the characterization of the activated clays showed the structural and morphological changes occurring after the activation processes. And the thermal activation was particularly useful because it also showed more noticeable changes, and it showed the highest performance in the Methomyl removal. Working at 40 degrees Celsius, we were able to achieve removal efficiency around 75%, as I said before. So our results fitted the Langmuir model in our case, which is also very common compared to some previous studies by different authors. And we believe that these results are very promising. Therefore, for future work, we are going to work with different clay activation parameters, particularly in the processes in which we will use acid and salt. And we believe that we will be able to obtain higher efficiency and lower costs for the treatment processes. That is going to be very important because in some cases when you want to remove this type of contaminants, we want to use a low-cost technology, low-cost material, and commercialization it's going to be possible only if we can reduce this cost. We also plan to work optimizing the process parameters. So we will be working with different pH, clay doses, and stirring rates in the near future. Finally, we also think that we should be able to work with different bentonites to see if there are better materials that can be used, particularly in my country, in Ecuador. Finally, I would like to acknowledge the support for this work from my university, Escuela Politécnica Nacional, and SET project. And of course, if you have any questions, I will be very happy to answer them. So thanks a lot for your attention, and I hope my presentation was useful for you guys and interesting. Thanks a lot.